What is going on, everyone? Jason, also known as Colonel Cottonbelt here. I've got an exciting update to share with you, and that's because I have been working on this on and off for the past several months on the new RR-Cirkits Tower LCC+Q, which I don't have the device in here because it's on the layout. But trying to learn the new programming for LCC, and there's not a lot of documentation out on the internet world on it, but I do have to give some credit to a few people because basically I took information from multiple sources and pieced it together, and I believe I've got it figured out. So the first person I have to give credit to is Dick Bronson, who is the CEO for RR-Cirkits. He has helped me tremendously over the phone, basically answering some questions. He has said that he has been putting a video or some better documentation out is on his to-do list. He just hasn't been able to do it yet. Another person is I came across a forum, found a video from a guy from the Oklahoma Railroad Club, Museum Club, I think, something like that. But it's an unlisted video, but I found a link on one of the forums, and he kind of explained a lot of the later stuff, but it wasn't dumbed down to the very beginner. And then the last person I have to give credit to is Dana Zimmerelli, Dr. Dana Zimmerelli, because he does have a PhD. This is his 2025 version of Layout Command Control, and it does touch into STL programming, which is what the new type of coding for LCC is. But I will be honest with you, it is not for a beginner. This book is designed for, well, the STL part of the book is designed for someone that's a little more well versed in STL, which of course I was not. So this has been a project that I have been working on since April of 25, and here it is December of 25. So it's several months in the making. So I'm going to switch the camera and just kind of show you that we've got a couple of signals here. Now, one of them I have pulled out, the one on the right. I have pulled it out of the hole and kind of angled it back so that way the camera picks it up better. You can see there is a signal on the left side, and that one is programmed. So these two signals, they actually have a little bit of complex logic in there, and so I'll explain here in a little bit why I went to the Tower LCC+Q to do all the conditionals and not on the signal LCC that they're actually wired into. And so we'll get into all of that. But you will have to just excuse the flickering of the LEDs. That has to do with the camera refresh rate not picking it up accordingly. And of course I have this business car sitting here on the track, and we're going to use that for testing purposes. And so before I get to explaining the different aspects of the signals and whatnot, you can see this is a double-headed signal. But we are going to pan up, and you can see there is a double crossover there. However, the double crossover is being treated as two individual crossovers. So I can either throw the left-hand turnouts, or I can throw the right-hand turnouts. I do not have mine set up as one throwing all four turnouts. I could, but the real railroads never did it that way. They either had it aligned for straight for both left hand or right hand. They never had left and right at the same time. Alright, we're going to zoom up a little bit, or pan up more, Now there is 2 other signals there. We're not going to be focusing on those today. That'll be in the future. But if you notice, there is a what appears to be a siding, and it's actually an open-ended spur. And then it's kind of hard to see because I do have some cars on the layout, but you can kind of see another piece of track going off, and it's headed to what appears to be the sawmill. So the track on our left has 3 more turnouts, 2 that are point facing and 1 that is frog facing, before it gets to the next double-headed signal, which you can see up ahead with a red over a flashing yellow. So we are going to have to add some extra rules and some complexity into the logic on this signal. Alright, so let me zoom back down, and what we'll do is we will cut over and I will explain the different aspects, what aspects we're going to be using, and what they're for. So I'll be right back. Alrighty, so I've got this signal PDF pulled up. This is the signal aspects of the Southern Pacific. This is data for 1996. Now, I know I model 1958. Totally get 96 is way after 58. But what I will say is that the rules of the signals pretty much never changed. The rule numbers might have, but the earliest, or not the earliest, but the only signals that I could find off of a website that keeps track of all these different railroad signals, they have one from like the 1930s, and it was actually from a pamphlet book. It was just images, and I figured that's going to be a whole lot more confusing to try to go through a whole bunch of different pictures, especially of things that are irrelevant, because it was mostly semaphores. So this is actual signals. Now there is some semaphores on here, like the semaphores right here that I'm circling with my mouse. We do have the Eastern Railroad, like Pennsy, B&O, C&O type signals here, but SP mostly use the searchlight style signals, which we have here. And I'm going to go ahead and explain the 8 different rules that we are going to use on our railroad. Alright, and we're going to kind of work from the bottom of the sheet, and then we'll work our way up. Before I get started, I will mention that if you go to page 2, and I'm scrolling here, you can see that the different rules actually gives more detailed information on it. Alright, so going back, like I said, we're using double-headed signals here. So to dumb it down for my operators that come and operate on my layout, the top head represents, hey, I'm going straight through the turnout. The bottom head represents that I'm going to diverge, whether it's diverging to the left or diverging to the right. I'm not going straight. And signals would only be protecting the main line. It would not be protecting anything else. So if you're coming onto the main and there's a multiple, 2 or 3 different route options, you could have a double-headed or a triple-headed signal. However, if you're coming on the main, or if you're on the main and there's only one direction you can go, it's just going to be a single head. Alright, in our instance, we're doing a double head. So let's go over all the different rules, and there's actually going to be 8 of them. So the first one is a stop. That's a red over a red, solid. Stop means stop. You got to have a stop signal. That means either a turnout that is frog facing, meaning that the points is on the opposite end. The points are not aligned for you to pass through, or it could be that a block is occupied. Alright, so first rule is stop. Alright, we're going to go ahead and go all the way to the top. Let's say that we are aligned to go straight, and there's nothing in our way, and the turnouts are all aligned properly. You could have a clear. That would be a green over a red. We're not going to be using darks on my layout. Full CTC, they would be dark signals, but we're not going to do that. We're just going to have a green over a solid red. Okay. you can think of my layout's going to be a little bit more ABS when it comes to the signals. CTC is going to be controlling the turnouts for a dispatcher to route trains properly. Alright, well, what if we're lined to go straight, but the next signal is a red? Okay, that means we're clear to go through. However, we need to know that our next signal is red. That's where Rule 9.1.7 approach comes into play. That would be a yellow over red. The yellow lets us know that our next signal is going to be a red over red. But what if the next signal was a yellow? Well, in that instance, we would have a flashing yellow over red. Now, that would be Rule 9.1.5. That's also called an advanced approach. That's just to let you know, hey, your next signal is a yellow. You can proceed going through a flashing yellow at the same speed that you would go on a green. Not every railroad had flashing yellows. The SP and the Cotton Belt did. So flashing yellow just lets you, it's like another, hey, to let you know, you just blew through a green, you're fixing to come to a yellow, which means eventually you're going to come to a red. Where if you didn't have the flashing yellow, you just blew through, you know, a green signal going full track speed, say, you know, 70 miles per hour if you're passenger, right? And then, hey, your next signal is saying that you got to slow down to 40 because you're fixing to stop. So the flashing yellow would give the engineer a little bit more time and awareness that, hey, I'm going to have to slow down. All right. So that's if we're going straight through. So you could have a green over red, a yellow over red, a flashing yellow over red to let you know that you can go straight through. Now, what if we're diverging? It's kind of the same thing. If we're diverging, going on the adjacent track, yeah, we will have to slow down some because we can't blast through, you know, a turnout going, you know, 70 miles an hour. Otherwise, we're going to derail, right? But it's the green is to let us know that, hey, everything's clear ahead. So to the next signal. So you could have a red over green. Just let you know that you're diverging. Is the diverging clear? Rule 9.1.8. Same thing. Well, what if the next signal is a yellow, a red, and we're diverging? Well, if it's a red, you would have a diverging approach, which would be a red over yellow. All right. And then, if our next signal is yellow on the diverging route, you could have a diverging advanced approach, which would be the red over flashing yellow. Now, we just went over the 7 most common rules. So it's red over red. We got 2 different greens, so it'll be green over red, red over green. Our 2 approaches, so it's going to be yellow over red, red over yellow. And then the advanced approaches, flashing yellow over red, and then red over flashing yellow. Well, what is the 8th one that I'm talking about? That's going to be this rule here, Rule 9.1.12, which is a restricting. And so that's going to be restricting speed. I like to use this rule to let people know, hey, we're either going into a yard or we're going into a spur. We're getting off the main line. Not necessarily we're going to a branch line, which might have been under dark territory, but this is to say, hey, you're going in an area where there could be crews or there could be rail cars sitting there in dark territory. You definitely don't want to be flying through that, right? Now, it also kind of acts as a red because a yellow would not just protect a red over red, but in a restricting phase, it could protect a lunar white, which I'm not using on this part of the layout, maybe in the future on other areas, but we're going to use a flashing red. Now, the other signal that I program actually has a flashing red over the solid red because that's going through the straight route. In this signal here, we're going to do a solid red over the flashing red. So that's to let the operator know that, hey, you're going to have to proceed at restricted speed. You're not lined to stay on the main. You're lined to go off the main in an area where there's either people or rolling stock that could be sitting there that could be in your way. You need to be at restricted speed. So that way, if you do need to stop, you can stop on a dime and not hit anything. Okay, so those are the 8 different rules that we're going to put in. So let's hop over and check out JMRI and open up the Tower LCC+Q, and I will show you how to start adding your different inputs and outputs, and we'll go from there. Okay, so let's get into JMRI and let's go ahead and program a signal. Now, one of the things that I did do is I did create me a little cheat sheet. This helps when you're not by the layout, and there's going to be times that I'm probably going to have to get up and down, so just be aware of that. You know, I might have to go and take this locomotive and go put it on the layout just to show that our block is occupied, or maybe push the business car. So let's go ahead and we're going to open up Panel Pro. Now, I know there is LCC Pro and there is a STL editor in there, but after conversing with Dick Bronson on that, he said that the STL editor has burned up a couple of his Tower LCC+Qs, so he prefers not to do that and has pretty much cautioned me not to do that. So I'm going to do this the old school way, and it's the safe way. So maybe JMRI can get something kind of figured out with that, who knows. Alright, so as you can see on the layout right now, this is my panel. We do have some occupancy here, and that's fine. This is the double crossover that we're going to be looking at. Like I said, I have it in as individuals because that's how the real railroad did things. Alright, we're going to go and open up LCC. We're going to go to Configure Nodes. So we're going to have a few different items opened at the same time. I've got my RR-Cirkits Tower LCC+Q here. I haven't even renamed it yet, so we're going to go ahead and configure it. Might as well just go ahead and rename it. I do have a Tower LCC that's over here in staging, and what I might do is I might replace it because it doesn't have any conditionals on it. It's just literally inputs, outputs. That's it. So I might replace it. I might not. So I'm not real sure what I'm going to do, where on the layout this is going. And I will say that I did try to program these signals through the old conditionals, which I'll briefly touch. But anytime you try to do something with 3 or more possible routes, especially when you have like a lot of different variables, it just gets haywire and it does not work properly. So I'm really glad that they did come out with this STL language, because it does allow for more complex situations. Alright, so the signal that I am programming is going to be in this node here. So it's going to be signal 110, and we're going to do the right one, so I'm going to go ahead and open it as well. And while it's loading, I am hunting down. Let's see here. And I'm just going to use this more or less for reference. So this one's got my occupancy detectors that is going to be involved. So I'm going to go ahead and open that one. We'll slide it over. Like I said, we're going to have a few different windows open here. So if you're like me and you have an extra wide monitor, or if you got dual monitors, it's very helpful when doing stuff like this. But also what's helpful, the cheat sheet. Alright, and let's see, this is the one that's got all of our turnouts. So we'll open that one up too. And I'm going to go ahead and minimize that. I will leave the panel open just for the time being, because we will need it. Okay, so, and I didn't even realize, okay, and I do have signal to a 1 on that one, so that's good. I might have to open up one more, but we'll find out. Okay, this is our main one here. No, it ain't. This has got the signal, so I'm gonna move it down. So I do need to open up one more. and that is the one that's got signal 101. And it takes a little bit to load up. Okay, so one of the things that you do have to do is when you're doing your signals, trying to find the right one here, I've got several, is you do need to get your rule to aspects set up. Just kind of briefly touching, you know, basically just create your mask, name it. You don't change this address at all, leave it alone. Lamp fade, you can leave it on none. I like mine on incandescent. But you can go in and create your different rules. So we already did 110 left, so we're going to do 110 right. And it's mostly already done, but I do need to add rule number 8. So we do have a stop. We have our standard approach, advanced approach, and our clear. Now here I've got, it says medium approach, and that's because in this list here they don't have a diverging approach. Okay, so they go by slow, medium, and whatnot. So I have that one as a medium approach. Rule 6, I did advanced approach medium. Rule 7, I've got a medium clear. And then rule 8, we need to add this restricting. So I'm going to go ahead and write that. Now I'm going to go back to my stop because I've already got my lamps figured out. So I know lamp head 3 red, head 4 red. Okay. So I'm going to come down here. I'm going to do head 3 red, go to lamp 2, head 4 red. And then on lamp 2, because it's a flashing red, I'm going to put it on an A medium. And we'll go ahead and save those changes. Any of these addresses here, we're not going to touch. We might copy it, but we're not going to touch. Appearance effects and effects lamps, I don't use those as well. I'll leave all that alone. Okay. So, now what we're going to do is we're going to pull open our logic inputs, logic outputs. So logic inputs, I've already got a few items in here, and I'll tell you where I've got them from. You can do this however you want to, but basically there is 16 different groups of inputs, and each input has 8 different inputs. So you do the math, 16 times 8, that's quite a bit. I could have done them, you know, all in sequence, but I kind of wanted to group items. So I've got the first group as these are turnouts. So there's 5 different turnouts that we're going to be looking at. The next group is blocks. So there's 4 different blocks that we could be looking at. Now if I go and add more signals on the logic here, then I can definitely add some more items. And I'll show you how to add this stuff here in a second too. And then the third group is actually one of the signals we'll be looking at, and then the second one is another signal. Now if it was the instance that, you know, group 3 here is a single-headed signal, it's only got 4 rules, but group 2 is another double-headed signal that's got 7 rules. If this was also a single-headed signal with 4 rules, I would have probably put both signals in the same grouping. But let's see here. So in order to add an item to that, I'm gonna go ahead and we're gonna use IO 0.5 as an example here. And I am going to find the one that's got our turnouts. So those are both occupancies. Here's our turnout. So port IO here. And let's say that I wanted to add this cascade receiving shipping turnout. So it's a Wiener turnout 1. Basically what I would do is put in the description. Just basically take this description. We're going to do a Control C, which is copy. come over here, Control V, it puts it in. And then we're going to come down here to the events where it says input on, input off. Okay, we're going to take and copy this input on event at the bottom, and we're going to paste it here. Now this tells us that it's closed. So I definitely do not like putting the closed one on the top. I like having the thrown one on the top, because if the turnout is thrown, we want it to be true, right? So I'm actually going to move that one down there, and I know this one here is going to be one number off, so I'm going to paste it there and just save my changes at the bottom, and that actually writes all three of those at one time. So now that is how easily to add a turnout to the Q logic. Alright, kind of the same thing for, let's see here, we're not going to need this, so I'm going to go ahead and minimize that one out now, because I just wanted that just for reference. But let's say if it's a block occupancy detector, right? Let's see here, I don't have Waldenberg, so we're going to go to the second group. It's kind of the same thing. You're just going to go to the line description, Control C for copy, Control V for paste. We're going to scroll down to input on, input off. We'll copy it. And we definitely want input on as true. That would be the block is active. Input off. Paste it there. The block's inactive. Save changes. Now we just added Waldenberg main 1. And for those who are new to the layout, Waldenberg is between the towns of Wiener and between the town of Hickory Ridge. So these signals are not protecting it, but the other signals that we saw that were facing the opposite direction would be protecting it. So eventually these would have to be added in there, right? Alright, and then I'm not going to add any signals, but to do the signals, what would you copy over on it? Let's see here. Here's a signal here, so we'll pull up the rule to aspects again, and there's my, signal 101. And basically, you're not copying this set aspect, you're actually skipping it. You're going to copy aspect is set, aspect is clear for each rule. So if you notice, I've got S101 stop here. We're looking at S101, and so you can see the E9, EA, E9, EA, but each of these inputs would be your different aspects for your signal. Now if you notice, there's 8 groups here, there's 8 rules there. Pretty simple. Now you could do the track circuits and do track receivers here, and I don't really know too much about it, but you could use this address here and then link it to that one there, and it could work. But I haven't gotten that far into using that, so I just prefer to put mine in as inputs. And like I said, 16 times 8, that's not a small number, so you have a lot of different logic inputs. Alright, outputs, same thing. Now this one we are going to have to add a signal to, because I do not have this signal added in there. Alright, so we are doing signal S110 right. So I'm going to basically take it, we're going to copy it, and let's see here, let's compress all these groupings so that way we don't see a whole bunch of extra that we don't need to see. I wish that when you pull the node up that these would automatically be compressed. They're not. They're expanded every time. So we're going to do S110 right, we're going to call it a stop. And it's kind of the same thing as the inputs. You're going to do the same with the outputs. Actually, no, you're not. You're going to do one thing and one thing only. We're only worried about true. So before, in the inputs, we looked at aspect is set, aspect clear. This time we're doing set aspect. So we're just going to copy the top one, and we're going to paste it. We're going to leave it alone. We're going to go to the next one, and let's see, S110 right. And this is going, oops, I just noticed I did the restricting on that first one. So let's go back to the stop, copy that and paste it there. It's a good catch, Jason. All right, now let's go over to approach. So we're going to type in approach. All right, I'm going to copy that top address, we'll paste it in, and so forth and so forth. Okay, now we've got all 8 different rules and their set aspect events put in. We're just going to go to the bottom, hit save changes. It's all in there at one time. That's what I love about that save changes button at the bottom. And that's how we're just going to put in our outputs. Okay? So now the next thing we're going to do is we're going to look at conditionals. Alright, now the beautiful thing about this is we're typing in code, and I'm going to explain all the code and how you can shorten the code. But you've got 16 blocks of logic here. Each block can hold 255 characters. Now sometimes, if you notice, I got logic 1 and logic 2 as the same signal, and that's because there's so much logic in this, and that's what we're going to run into this one here. It's basically the same, almost the same rules just about, that it's okay if you don't get it all to fit within 255 characters. You can just continue on to the next block, and so the way that the information is read is it reads from block 1 to block 2 to block 3, block 4, all the way through block 16, and then it goes back and reads through block 1 again. Alright, so one of the things that we definitely cannot do, or that the system will not allow us to do, is to loop back to a previous logic. So you have to go forward. Alright, so we're just going to go ahead and start in logic 3. Now I do have 144 available characters here, so I could start here in logic 2 if I really wanted to conserve space and use it to program extra signals. You can program more than one signal in one block, but just for transparency and to keep things nice and clean, I'm only going to put it in, I'm going to start in logic number 3. So we're going to do S110 write. Go ahead and write the name for that. And so the first thing that I want to do is I want to clear out. So we're going to do CLR for clear. And I'm going to reference back because I've only done one signal, so I just want to make sure I've got this set right. So clear equals, and we're going to do all of these different Q inputs. So first one's going to be 1.0 equals Q 1.1 equals Q 1.2, and so forth and so forth. Now I will tell you that your letters do have to be capitalized. If it is lowercase, it will not work. Alright? Now, the next thing I'm going to do is go ahead and put in our set address for, this would be Q, so set equals, equals Q 1.3. That should be our clear. So we got stop, approach, advanced approach, clear. Okay? So, and then the other thing I'm going to do is I'm going to put in a jumping conditional, and so our jumping conditional is going to be exit 31, and we'll probably change it to 41. And so this was one of the guy from the Oklahoma Railroad Club. This is his convention, And his convention is so smart that I'm just going to adopt it. I suggest you do the same. But his convention is E stands for exit, 3 stands for which block you're in, and then the number after the block means it's the first one. Or if you had 2 signals on there, then you could have one for the first signal will be the first one, and then have a 2 for, clearing out the second one. Alright, so it's just a jumping conditional is all it is, but we're going to add some lines of several lines of logic. And like I said, we're going to have to take some of this and move it over to logic 4. Alright, let me take a quick little break and I will be right back. Okay, we are going to continue. Had to take a quick break. But I went ahead and rearranged the screen so that way hopefully y'all can see things a little better. Basically have the signal right now showing a green over red, which it's supposed to. And we're gonna work on the logic. So basically when it comes to logic, you're gonna have 6 main commands that you're worried about. And in my instance, I'm only going to use 4. And these commands are going to be AND, which is represented by the letter A, and NOT, represented by AN, OR, which would be O, and OR NOT, which would be ON. And I don't even think I'm really going to use ON. I think it's more or less going to be A, AN, and O. So let's go ahead and start writing our first thing of logic. Now, when you're writing logic, you've got to be the most restrictive. So we're going to do everything for red first. Alright, so the first thing, no matter the turnout in front of us, the double crossover, it's 2 separate blocks. So we've got main line 1, main line 2. Now, I've already got everything written down on my cheat sheet, and that's going to make my life a lot easier. I suggest you do the same. So main 1, that passenger car kept rolling, whether it's diverging or going straight, it's going to enter the first block, which is going to be input 1.3. So I want to say AND, so it's a true statement, so that would be AND. If it was a false statement, we would say AN. So AND input 1.3, we want to equal Q 1.0. That's the stop. And then we're going to do a jumping clause and then E31. Alright, we're going to write this, then we're going to do a restart. Let it reboot. Give it a second. Let's check our syntax messages. And we have no errors. So it refreshed. Success, no syntax errors. So I'm going to go over to the car and let's see if we can get that signal to change red over red, and then I'm going to move it back and get it to clear. Okay, so you can see that the signal did change as I was physically moving the car. So now the next piece of logic is going to state about our first turnout. And so this is where we have to start including, is the turnout in the closed position or is the turnout in the standard position? So this is going to be, we're going to say A, and we're going to do N and not, because I do not want this turnout in the thrown position. Input, this would be 0.3 for this turnout, okay? And input 0.4, okay? So basically what I'm saying here is 0.3 is the first turnout, so that's the turnout we're coming to. 0.4 is going to be the second turnout. So not including we're saying 0.3 is in the false statement by saying and not, we're wanting to say that's going to be straight. But if 0.4 is in the thrown position, which would be a true statement, then we want our signal to be red. Okay? So we're going to say equals Q 1.0 JC space E 31. And I'll show you here in a minute how you can really save some space. Let's write that. Let's do a more. We're going to restart our node. So at the Tower LCC+Q, you do have to do restarts. And we're going to do a refresh on the syntax, no errors. Now let's see what happens when I throw the switch. Alright, our signal did go to red like it should. If I throw it back, it goes green. So that's perfect. Alright, next line. We're going to do AN 0.3. I'm sorry, ANI 0.3. And then the next, let's say that the block beyond the turnouts, where it's going over the grade crossing and all the way to the next signal, that's going to be input 1.1. So that's a different block. If it's occupied, we also want a stop command. Alright. So we're going to write it. We're going to restart our node. And we're going to refresh it. No errors found. So now if I move my locomotive into the block from the other side, I should get a red signal. So we're going to check that. Alright, now you can see our signal is red. So I'm going to move the locomotive out of the block. Okay? And it cleared back green like it's supposed to. Alright, now we got to do the diverging. So, since we are diverging, now we're going to say if turnout or input 0.3 is true, well, that block is going to be 1.2. So I'm doing A 1.2 equals Q 1.0 JCE 31. Okay? And then we're going to do the next. So the block 1.2 is going to be the other main. So once it starts crossing into that main, then it's actually, that double crossover is 2 blocks when you're diverging. Whether you're going left to right or right to left, it doesn't matter. You're crossing in 2 blocks. Alright. We're also going to go ahead and do the next block. So, which would be 1.0 equals Q 1.0 JCE 31. I'm going to go ahead and write both of these. And we'll go ahead and restart. Just like so. Check for syntax errors. We have no syntax errors. Now I'm going to take my business car and I am going to roll it through the double crossover. Let me go ahead and get it lined. There we go. And I'm going to roll it through the double crossover and we're going to see if we keep a red signal the whole way through. Okay, so you can see that our blocks stayed red, which is good. Now I've got another turnout So if we're following this line here, going into this turnout is fine, but this is the turnout we got to be cautioned for. If this was thrown, then we need to make sure that we have a red stating that we can't proceed. Okay? Because the next signal is over here by this turnout, and I know it's not on my panel, but it's over here by this turnout. So the signal is like right here. So if this turnout is lined, then we're going to be fouling. So we got to add one more item. So AI 0.3, and we're almost out of characters, y'all. And that is going to be 0.0 equals Q 1.0 JCE 31. Okay. Right. We're going to go ahead and restart it. And let's check, see if we got syntax errors. We do not. Now let's see if we throw this turnout. Oh, I noticed that we have a red over red. Y'all see that? Now if I threw this turnout, let's see if it goes green. It went green. So now this is backwards. So this is a great thing about troubleshooting. What I can do now is just put that in right here, and that's going to reverse the logic on it. We'll write, restart. Now you can see the signal is showing a red over red, and when I put the turnout back, now we have a green. Okay, and as you can see, we only have 39 characters, space of characters left. That's a lot of different rules for the to set to to one signal output. Well, we can eliminate a lot of this repetitiveness where it says equals Q.1.0 JC E31. We can eliminate a lot of that, and we can start off by changing this A to an O and saying OR. And basically, we're going to put parentheses, whoops, in front of all of these. And we're going to put closed parentheses behind all of these. Alright, and then we'll go back in front. We're going to add capital O's. And then what I'm going to do is I'm going to start backspacing. And we're going to put all of this on one line. Now I only did this for demonstrative purposes. When you start doing your logic, you can go ahead start doing it. What happened there? Oh yeah, okay. So basically now we're saying or this and this, or this and this, or this and this, or this and this, or this and this will set that signal to 1. We'll go ahead and write that. Now let's see what happens if we throw this last turnout. It went to red, right? Just like we wanted it to. What if the double crossover gets set? Well, that didn't change it. Okay, now it did. So that changed it if we're going straight. You know, if we're diverging, it really doesn't matter, right? So now it's back on green, and I'm sure if I moved the car throughout the whole thing, it would go red. The main one that I really want to pay attention to is the first one. So I'm going to check it one last time, and then we'll start adding the signals. Alright, so that did exactly like I wanted it to. Alright. gonna go ahead and restart it one more time. And we'll check for syntax errors. We have no errors. It's always good to double check your stuff. See, if this is turned and we're lined straight, it don't matter, right? It's only when we are lined to go across. Oops, now we're fouling. So, yep, so it's working just like we want it to. All right, now let's start looking at putting in the lines for restrictions. So if we are diverged over like this, and let's say that we're going into Cascade lumber, or if we're going into Rosslyn, either or, we want a red over a flashing red to show up, okay? So we're going to go down a line, and so we're basically going to say that if AI 0.3, so that's if our first turnout is set to diverge, okay? Then we're going to say and we're going to create a nest. So the nest is the parentheses, but here we're going to say or, all right? And that will be input 0.2 or input 0.1, close parentheses, and then we're going to do equal Q 1.7 JC E31. Let's write it, more, and restart. Now, I didn't have to do anything with the blocks and stuff because all of that information is up here. We don't have to be redundant with everything else. We're only adding in new variables. Okay? Let's check our syntax. We have no syntax. Now, look at that signal. It's flashing red on the bottom if you haven't noticed already. Alright, I'm going to close Rosslyn off. And we still have a flashing red. I'm going to close Cascade off. Now it goes back to green over red. Now, if I threw this switch and had Rosslyn lined up, it doesn't matter. But as soon as I line Rosslyn up, now we have our flashing red, just like what we wanted. So our restriction is in place. Now we're going to look at diverging. Okay? So we're going to go back AI 0.3 because we're stating that that first turnout is in the diverged position. And now we're going to look at the signal. If our signal is a stop, that signal is input 2.0. So AI 2.0. And we're going to want to make this a diverging approach. So our diverging approach should be 1.4 because our clear is 1.3. All right, we'll go ahead and write that. So now I'm going to have to pull up the other signal. So that's going to be signal 101. So I'm going to get it pulled up on the screen. Get the rule to aspects pulled up. And I'm going to show you a way how you can easily trigger some of this. So I'm going to make some adjustments here so that way y'all can see exactly what I'm looking at. Okay, so if I go to rule 1.1 and I come down here to the set aspect and I did more and trigger, okay. Oh, you know what we didn't do here? We didn't restart our node. So let's try restarting the node. And let's go ahead and throw it back into diverging. There we go. And let's make sure we have no syntax. Okay, so we have no syntax. So I'm going to go ahead and trigger this again. Now we have a red over yellow, like we should have. Okay? So let's go ahead and see if we can get one more line. So AI 0.3 because we're still in diverging. But here we're going to have to create a nest because I got two different types of diverging, right? So here, if it was yellow over red, which I have as, so I'm doing an OR on this one, 2.1, whoops, 2.1, or a red over yellow, which would be 2.4, like that, then I want that to equal Q 1.5. JCE 31, and I'm probably fixing to run out of characters. But I'm going to show you what you can do. Yep, I'm out of characters. So one of the things you can do is come up to one of these lines and you can take these spaces out. Spaces, they're nice to keep things nice and clean, but not required. Okay? Now I've got a few extra characters. I can put this E31 back in and do that. We're going to write more. We're going to restart our node. Alright, check for syntax errors. Okay, now I got an error in logic 3, line 4. So 1, 2, 3, 4. Oh, right here. I forgot to put a 3 right there. So let's write more, restart again. Now I have no syntax errors. So that's perfect. So now, yep, we're back to the green over red. So now if I go and do an approach and trigger it, now I have a red over a flashing yellow. Now I'm going to send it back to a stop. Now we have red over solid yellow. And what about the diverging approach? Let's check that one. Red over flashing yellow. So that is correct. Okay, well, I've only got 5 more characters on this section here, so we know that's not going to be enough. So what I am going to have to do is we are going to have to go into logic line 4. So we're going to write it, and I'm going to take these last 2 lines here, I'm going to cut them out, and I am going to paste them on logic line 4. We're going to go, shoot, shouldn't have done that. Let me write that. Let me go back here, let me write this. Now let's restart it. Hopefully I didn't mess up, but we're fixing to find out. Alright, let's see if we get a flashing red. Okay, we do. Perfect. Okay. And let's see if we get, I'm going to trigger this diverging approach on the next signal. Yep, we still have that, and there's our diverging approach on this signal. Okay, so that's all good. I've only got 21 characters left, so let's see, the next thing we would need would be diverging clear. And for diverging clear, that is going to be a pretty big line. So I do not think I'm going to be able to get that to fit here. So we're just going to go ahead and forward on to the next line of logic. And so, let's see, we're going to start off with AI. So AI 0.3 again. Okay. And we're going to do a nesting. And so now this would be flashing yellow over red, green over red, red over flashing yellow, red over green. So we've got a lot of different options here. Alright, so this would be OR, a lot of ORs. So flashing yellow over red is going to be 2.2. Or input green over red is 2.3. Or input a red over a flashing yellow is 2.5, or input red over green is 2.6. and we're going to want to equal Q, and this is going to be, let me verify, should be 1.6 because we did 1.5 as the last one, so this is going to be Q 1.6 JCE. Now I'm going to make a change because now I'm in logic 4. I'm going to go 41 and I'm going to change that to a 4, but then now I have to come back here and change all of these 31s to 41 so that way my convention is correct. Alright, so we're going to write all that. We're going to come over here. We're going to make sure that's written as well. More, restart. So the node is restarted. We're going to refresh. I see no syntax errors. So that's perfect. So now I should be able to go through all 7 rules and we should see the signals line up correctly. And actually, if you're looking at, it's showing a red over green right now. So that tells us that it is looking correct. So let's do the stop command. So we should have red over yellow, which is perfect. Our approach. So we should have a red over a flashing yellow. Perfect. Then the next one's going to give us a red over green, which we have. Then of course the next one would give us a red over green, which it stayed. Then the next one should give us a red over flashing yellow again. The next one is going to give us a red over green. And then of course last but least, just to test it, the last one also gives us a red over green. So now we have everything for the diverging done. Now, as far as doing the main, or the, staying straight, we're not going to have to do near as much logic because there's not a lot of extra turnouts. And so really the only thing we need on it is I've got to find the signal for it so I can open that node. So let's see here. Lights, turnouts. Okay, right there. I was overlooking it. Okay, so I'm going to pull this node up here. Just takes a second to pull up. Okay, we're going to go to rule aspects on it, and so this is going to be 201 north. And this one's only got 4 rules, so this one makes it real easy, right? So let's add one more line of logic. We're going to do ANI 0.3. So now we're basically saying that the turnout is straight again. And we don't have to look at any other turnouts. We don't have to look at any other blocks. All we're looking at now is the next signal. If the next signal is red, so we're going to say AI, and it's 3.0, so it's on input 3.0. Then I'm going to want to say is Q equals 1.1 JCE 41. Now just to make sure that it is 1.1, we can go back up here to logic outputs, and we see 1.1 is S110 right, so I've got 2 signals called S110, but the right one is on the approach. That's what we want. So we'll go ahead and write it. More, restart, let it reboot, check for syntax. We have no syntax errors, and now I can come over here and first let's get our turnout line back up, right? Okay, it's detecting some type of occupancy in our block here. So our block, the next block is red because there is occupancy there. I believe I got a locomotive in it, and I do. So now we have the correct signal with a yellow over red. Alright, next one. This will be the last line of logic we're actually going to have to put in. So ANI 0.3, AI 3.1. So this is if the next signal is a yellow. We're going to equal Q 1.2. JCE 41. And I can actually take out that line of logic there. And then this basically states that if nothing on any of the lines of logic that we put on logic 3 or logic 4, then it goes to Q 1.3. So let's write this. We're going to restart it just to double check. Alright, check for syntax. We have no syntax issues. Alright, so we're currently on a stop. But let's say I'm going to force the trigger of an approach on that next signal. We have the flashing yellow. I'm going to force the flashing yellow on the next signal. We have a clear. And then I'm going to force the clear on the next signal. And it stays clear. So there you go. That signal is now officially programmed. Well, I hope you found that information helpful to you for those that are learning LCC. And if you're wanting to learn about LCC but you don't know where to go, feel free to shoot me an email. You can email me at support@trainfreakhobbies.com. I am a distributor with RR-Cirkits, and I'm still growing my knowledge on LCC and all things LCC. But like I said, I am a distributor with them, and I'm also a distributor with Custom Signaling Systems as well. I do sell their equipment on my website, and if there is something, as far as the signals, if there's something that you want customized, you can email me about that as well, and I can definitely help you out. So other than that, like I said, if you enjoyed the content or if you did find it helpful, show me your support by thumbing it up. And if you want to follow more great content, make sure that you hit that subscribe button, and then fill in the bell so that way you'll be notified when I come out with the next video. Okay, so other than that, I'm gonna let y'all have at it. Thanks for watching. Y'all be safe out there. Happy railroading. Take care.